FYI, I'm just recording this lesson today for a couple people that are gone and requested it. We are on the last lesson of chapter 4. Today we're doing something a little bit different. It combines log laws, which we learned back in Pre-Calc 30. So I've just written them on the board here. Those would be back in your Pre-Calc 30 notes. So you're going to have to maybe write these down at some point so you have them fresh, or you can take a picture before you leave. Jot them down somewhere because they're not on the formula sheet because it's like a Pre-Calc 30 concept, okay? But we're going to combine log laws with implicit differentiation today, okay? So this is called logarithmic differentiation. So what we're going to do for every single question today, I have your 3 steps listed out here. You are going to take the log, and we're actually going to do the natural log today. We're going to take the log of both sides of an equation. You did that in Pre-Calc 32 when you were solving exponential equations to bring the exponent that was up high in the sky, to bring that down to earth to be able to solve for it. You had to take the log of both sides of the equation. Then you use log laws. So that's not new. So we're going to take the log of both sides. And then also in step 1, it says to use the laws to simplify. Okay, so step 1 is log stuff only. We're not taking the derivative of anything in step 1, just using log laws and simplifying. Then step 2 is where we start the differentiation thing, which we have been doing this whole unit and all of last unit. And then step 3, we isolate our dy over dx, or our y. Okay, so steps 2 and 3, you know, that's differentiation. We've been doing that for 3-4 weeks now. Step 1 is kind of what's new today. We have to bring these log laws back. Okay, so I suggest writing nice and neat and small today. There's quite a few steps, especially for the last 2, C and D. A and B aren't too bad. Okay, so we have this equation, okay, and I want us to use logarithmic differentiation. So step number 1 is to take the natural log of both sides. So I set my left-hand side, the natural log of y now, and then the natural log of x to the power of root x. Okay, so all I've done is put an ln on each side. All good. Okay, after you take the natural log of each side, that's where you're going to use these log laws. You will never be able to do anything on the left. Your left-hand side is always going to be y. There's nothing we can do. Okay, it's not a product, it's not a quotient, it's not a power. So these log laws don't apply. But on the right-hand side, I have to do whatever log laws I can here. Okay, so I'm going to use the power log law because I see a power. It's not a product, it's not a quotient, it's only a power. So if we look here, the power log law says you just take the exponent and you pop it down in front of the entire term, in front of the entire thing. So that means that this root x, my exponent, is now going to be entirely in front of my ln. And then you just have the x now. Please don't subtract 1. We're not in the derivative mode, right? So you'd be tempted, because we're so used to doing the power rule for derivatives, to pop it down in front, then -1. We're not there yet. We're just doing log laws. So log law, you pop it down in front. Okay, so now that we've done the power law, there's no other log laws we can do because it's not a product. There's only one log. It's not a product. There's no quotient. So at this point here, we move on to step 2. And step 2 is where we do implicit differentiation. Okay, so I am going to, just like we've been doing, take the derivative of each side. I can't really fit that, but we are taking the derivative of each side. You are used to that. Okay, so now we shift our brains to derivative mode. We're out of log mode, we're into derivative law mode, okay? So I want the derivative of ln of something. We did that yesterday. Whenever you take the derivative of something with an ln, it's always 1 over whatever's in the bracket, which is y, And then you have to always multiply it by the derivative of y, but that's just 1. But I did take the derivative of something with a y in it, right? So we know implicit differentiation means we slap that on the side. Okay. Now on the right-hand side, I have to take the derivative of root of x times ln x. That's a product. So because we're taking the derivative, this is item number 1, this is item number 2, right? I have to do the product law. So product law says you take the derivative of your first guy, root x. And I told you guys to memorize this like a month ago. The derivative of the square root of x is 1/2 x to the negative 1/2. I slapped that 1/2 down in front and I subtracted 1. Then the product law says you multiply it by the second guy unchanged. Cool. Then we add and we reverse. So now the derivative of the second guy, derivative of ln x, whenever you have an ln or a natural log, it's always just 1 over whatever your x is, which is just x. In theory, it would be times 1 because we have to find the derivative of x. I'm not going to write that. And then you have to remember to multiply that to the first guy in your product law unchanged. Did I take the derivative of anything with a y on the right-hand side? No. So here's what I have now. So at this point here, we have to still isolate that guy. That's always our goal. When we did implicit differentiation the last month or so, we always factored it out, right? We don't have to factor it out because there's only one of them. So all we have to do to isolate this highlighted part is what? How do I get rid of 1 over y? Tad? Multiply both sides by y because all that will cancel, right? But what you do to one side, you have to be fair and do to the other side. So I am times, and it'll be that way every single time. Okay, you're always going to times by y. All right. Okay, so now what I'm going to do is I'm going to rewrite my left-hand side isolated. And on the right-hand side, I'm just going to clean up a little bit. So I'm going to simplify a little bit. I'll tell you now, in the solutions for these exercises, like those orange packages, Mr. Palmerine does quite a bit of simplifying throughout. So if you want your answers to match his, you're going to have to try to simplify a little bit. So I look at my first term here. That's one big fat term because they're multiplied together, right? The way that Mr. Palmerine in his solutions would simplify that is you have an ln x up top and you have a 2 root x underneath, because this negative exponent actually can get sent down to the bottom, and I put it back into root form. It joins up with the 2 who is already on the bottom, and then that ln x just slides to be over top. Yes, Tad? Not quite yet. Hang on. Hang tight. Okay, so I'm just simplifying first. All right, so I'm going to erase this arrow. So we still have a bracket because Tad is right. We still have to remember we have that y waiting for us. And then over here, I can just slide those. Now, I will let you know, we're still times y, that whenever you have this situation, a root x over x, you can leave it like that for me. That's just fine. But I was looking at some of the solutions and Mr. Palmerine always simplifies that. So I'm just going to show you what that simplifies down to, and I'm going to write it over here. Okay. So this is actually x to the 1/2 over x to the 1, right? If you subtract them, because it's a quotient, it's like that, right? Which would be x to the 1/2 over 2 over 2, which is x to the negative 1 over 2, which goes back down. Okay, so this simplifies to that, and that is what Mr. P will always have in his solutions. Okay, by all means, you can keep it like this. I'm cool with that. But if you see that guy, that's why he just simplified it down. Okay, now what we do next is actually very easy. We do not have to distribute the y in. This is the final step. The final step is you go back to the top here and you see that y is equal to x root x. And we want our final answer to be x's only. We don't want to have a lingering y. So all we do is replace that y with whatever it was equal to in the beginning, and it was x root x. Now our final answer is all in terms of x, and that is the answer. You do not have to distribute that guy in, okay? And that's logarithmic differentiation. So we do log laws first, then differentiate, then sub back in. Let's do another one. All right. So this one just got a whole lot more complicated, didn't it? Follow the steps. Step number 1, take the natural log of each side. Don't change a thing. You're just writing an ln on both sides. Okay. So once you take the natural log of both sides, you are in the log law world. We are still in step 1. So we see here we have a product up top, and then we also have a quotient. Okay, so we're going to use the product law first. So the top two guys that are a product are going to get split. And then the bottom guy, which is a quotient. Oh, I wrote this wrong. It should be minus. Pardon me. You subtract. I don't know why I did that. Minus log b of n. So whenever it's a quotient, you subtract it. So this is what it's going to look like. Again, your left side won't change. Your left side is very patient this whole time. All right. So the first thing I'm going to do is I'm going to separate these top two terms with the plus sign in the middle. And that ln gets sent into all of them. When you split it up, just like the laws here, each of them get a log when they're split. So I have that, and then I have another one, and I am going to change that radical to a 1/2, because if I'm looking ahead and I'm going to simplify, I know I can use the power law whenever you have an exponent on the outside. So whenever you have a radical, it's good practice to change it to an exponent. Then we're going to minus off that quotient. So we are minusing off that 3x squared guy. And now we have no fractions. Life is good. Do you guys remember that from pre-calc 30? The splitting and adding and subtracting? Okay, so now we are not taking the derivatives yet. We are still in step 1. Step 1 is to completely simplify all the logs possible. So I have done the product and quotient law. And now I can see with what's left, I still have powers. So we still have some simplifying to do. So again, your left-hand side is remaining very patient. Okay, I have a power law, so I am popping him down in front. Then you rewrite the log and you're left over x. You are not subtracting 1 off. We're not doing derivatives. Okay, then you plop that 1/2 down in front, ln, recopy. No chain rule here. We're not doing derivatives. And then here, plop the 5 down in front, recopy. Don't you dare write a 4. We're not in derivative mode. So you really have to split your brain into 2 modes for this stuff. We're just in log mode. Okay, now every single log law has been used. This is totally simplified. This is where we can finally move on to step 2. And step 2 is where we start the implicit differentiation process, okay? So I take the derivative of this whole side and the derivative of every term on my right-hand side. Okay, your left-hand side should never be a problem for you. It will always be the same because it's always going to be y. The derivative of ln y is 1 over y, and you don't forget the dy dx. Okay. You have 3/4 times ln, the natural log of x. The derivative of ln x is 1/x. Always. That should be something you should just memorize, okay? But you still have this number out front. So it becomes that. That 3/4 just stays the same. It's kind of like a constant, okay? All right. Then we take the derivative of ln of x squared plus 1. Whenever you take the derivative of ln, it's 1 over that. But don't forget, you also have a 1/2. That's just going to stay. So whenever you have a coefficient, it just gets rewritten. Don't worry about product law or anything. That it just gets rewritten. And the derivative of ln of that is x squared plus 1 on the bottom. But now I do have to do the chain rule. The derivative of ln x is, yes, 1 over the x, but then we have to take the derivative of what we recopied. So the derivative of x squared plus 1 is 2x. Okay, next one is minus 5. That gets recopied. It's your coefficient. ln means we go 1 over the 3x plus 2. And then we have to multiply that by the derivative of 3x plus 2, which is just 3. Okay, so to help yourself with simplifying, to get your answers to match the solution key as much as possible, what I suggest you do next is go term by term. You have 3 terms on the right, and simplify and clean up what you can. Okay, before we even isolate on the left, we're just going to clean up my right-hand side and kind of write them as more cohesive fractions. So this first fraction here, the 3 slides on top, 4x together on the bottom. That one wasn't so bad. Okay, your second one, I highly recommend crossing off what you can. These are all multiplied together, so I know I can cross anything top and bottom, and that's all I can cross off. And so on top, I just have 1 times 1 times x, and on the bottom, x squared plus 1. Don't you dare do that. That is child's play. I am teaching that to my pre-calc 20s right now. You absolutely, positively cannot do that because he doesn't have an x. It has to be all or nothing. Do my guys remember me saying all or nothing? You can't just pick and choose 2 out of the 3 terms to reduce like that. It's got to be all of them or you can't do it. Okay. And then here you have a minus. Nothing can cross off. 15 over 3x plus 2. All right, that's a little bit cleaned up. Now we're at the point where we multiply each side by y so that my dy over dx is completely isolated. And because I just did all of that work for cleaning up, there's no more cleaning up I have to do. I'm just going to recopy these guys. And then my final step is to replace or sub out that y with whatever y equaled in the beginning, which was that whole big thing. But you just recopy it. It's not too bad. And now the entire thing is written in terms of x. You've got your y isolated or your derivative of y isolated, and that is the final answer, as gross as it can be. Could you imagine if I made you distribute? AP kids might have to. We're not going to do that. Okay? Or maybe that's like a bonus question or something. Okay. 2 more. We're going to kick it up or pick it up a notch now because we know what we're doing. I think I'm going to go a little bit quicker now. This is very similar to the question we just did in terms of we have a multiplication on top, a division on the bottom. So we're going to split them up the same ways we just did for B. So I'm going to take the ln of both sides. To save room, I'm just going to be lazy and write it like that. We are taking the ln of each side. So when I do that, my left side is always the same. It's going to be patiently waiting as an lny for now. Okay, let's split them up. So I'm going to have the natural log of e to the x, this is my first guy, added to, because I'm doing the product law for logs, natural log of this guy, and once again, I'm going to change him to be to the exponent of 1/2, and then I am minusing off the natural log of my bottom guy. And remember, every single one of them gets an ln. All right, we're not in derivative mode yet. We are still in log law mode. You have to use all your log laws possible. Okay, this is a unique example because of this guy right here. We learned way back in chapter 1, it's actually on your formula sheet too. The natural log of e to the x is always equal to x. That's on your formula sheet. We did it in chapter 1. I don't expect you to remember. It was a while ago, but it is. So again, I'm not taking the derivative yet. I'm just simplifying. Just simplifying. So I know ln of e to the x is always just x. So that's something I can simplify. So ln y equals x. Okay. Did you find it, Sophia, on your sheet? Should be there? No? On there. Other ones are. These log laws are, but just in different form. Okay, well, it's in your chapter 1 notes, I promise. I know I put it there. I think it was lesson 3 or 4. There's a little table, and it tells you that ln of e to the x is x. Okay? All right, next one. I see a power, so I'm going to use the power rule, the log power rule, which means the 1/2 plops down in front of everything, and I just recopy. No derivative business yet. And then -3, recopy your ln, x squared plus 2. Okay, now we've done all the log laws possible. Now we take the derivative of each side. Your left side is always the same. The derivative of ln y is 1 over y, but we have to remember dy over dx. So don't screw up your left side. It's a gimme. It's always going to be the same. Okay, now we're taking the derivative of each term here. The derivative of x, 1. Okay, I explained in the previous question, whenever you have a coefficient like that in front of a natural log, you just recopy the coefficient. The natural log law is, natural derivative law, I should say, is 1 over whatever is in the bracket, but then you have to multiply it by the chain rule now, because we are in derivative world now. Okay, same thing here. We're going to minus that 3 off. It's going to stay a 3. I flip and I go 1 over x squared plus 2. And again, I go times 2x. Okay, my next step is always to clean up my right-hand side and cross off and simplify as I go. So the 1 is a 1. Now, in the second fraction, similar to the previous question, I can slash off those 2's. And I just have an x all by itself over x squared plus 1. And then here in my third guy, I can't slash anything off. All you can do is combine the 3 and the 2. So we might as well do that. So we actually have 6x all together over top of x squared plus 2. All right. We've taken the derivatives of everything. The last step is always the same. You multiply by y so that we can isolate our dy dx. And so our last step is just recopying and then subbing out our y for what it equaled at the very beginning. So we have to recopy this whole beastly fraction here. All over x squared plus 2 cubed. Close it up. It's huge, it's nasty, but that's it. All right, we're going to do one more. This is it, last one. I wanted to do one where there were 2 terms on the bottom. So when there's 2 terms on the bottom, you minus them both off because they're both on the bottom. So the first one gets minused off and the second one gets minused off also. Okay, so step number 1, ln of both sides. Okay, ln y, as always, is just going to wait patiently for us to do our business on the right. Okay, so first of all, I have the natural log of my numerator, which is x to the 5. And he's the only guy up top. So I just write him down. Now, because I have two guys on the bottom, I am minusing both of those guys off. So first I minus off natural log of 1 minus 10x. And then the other guy is also a quotient, so I minus off him as well. So natural log, and I'm going to, again, flip it to be an exponent instead of a radical. So x squared plus 2 to the power of 1/2. Yeah. No, it's because there's two binomials. So whenever you have two binomials, you need to have brackets around both binomials. Yeah. Okay. So now we are still in log law mode because I see powers kicking around. So ln of y. So I am going to pop that 5 down in front. ln. Someone's going to be tempted to write x to the 4. Okay, I know it. Just try to remember we're in the log law world right now. The power plops down and that's it. Okay. With this second guy, I can't do anything because there's no power. It's not a product. It's not a quotient. So he just gets recopied. But then this guy, I can plop down that 1/2. Recopy, and I don't subtract 1. I'm not in a derivative mode. Okay, now my log laws are done. Now I get to shift to derivative mode. So I take the derivative of each side. So once again, derivative of the natural log of y is always 1 over y, and then you write your dy dx. Okay, so derivative mode. The coefficient stays, and natural log of x becomes 1 over x. If you're so smart, you could just write 5 over x right away. If you know that 5 times 1, if you're like looking into the future, but by all means, keep it like that. All right, now I am minusing off just the natural log of that. There's no coefficient, so it's just right away 1 over whatever's in the bracket. Don't forget, you need to multiply by the chain rule. 1 minus 10x gives us a derivative of minus 10. So don't forget that. Okay, and then now I recopy my coefficient of 1/2. Derivative of this guy is 1 over x squared plus 2. And again, don't forget your chain rule. 2x would be attached. Okay, so now, before I do anything, I like to go through and simplify at this step. So I would have 5 over x. Then I'm going to have a positive 10. I just brought the two negatives together over 1 minus 10x. Don't you dare cross off those 10s. Only 2 of the 3 terms have a 10. You can't cross them off. Here, I'm going to cross off the 2 and the 2, and I have a minus 1x, or just minus x over x squared plus 2. And now you're at the point where you can go and you can times y to every single side. So just to save us some time here, I'm just going to write it right here, right? So you would go and you'd multiply y to both sides, but y is actually that whole beastly thing I gave you at the beginning. Okay, so that's logarithmic differentiation, shifting between the two worlds of logs and derivatives. Okay, so you got to kind of be on your game to not mix up the two. All right, we're going to discuss now how we feel about our exam. I told you yesterday we would kind of wait to see how we felt with this chapter, or this lesson, sorry. Yeah. Oh, sorry. Yeah. That's really quick. I forgot about the back. Okay, sorry. This one will take us 2 minutes, not even. Okay, do you remember how we've done 2 proofs so far? This is a 3rd proof, but it is very light. Okay, it's like almost like grade 9 rules apply. That's it, just like exponent laws. Okay, so we proved that the derivative of e to the x is e to the x. That was the first one we did. We proved yesterday, the second rule was the derivative of log is 1 over x times ln. Okay, today we are going to prove the power law, the derivative power law. So what I'm talking about is, let's go back to the very first day we did derivatives. If I gave you something like this, you would use the power law and say it's 5x to the 4, right? You'd pop that 5 down, you subtract 1. We are going to prove that. Now, on your exam, I am telling you now, I give you these 3 proofs or 3 options of these 3 proofs. You have to do one. You have to prove one. And I'm telling you now, you get to decide which one. Okay? This one is pretty simple in terms of like the rules and the math. Okay? So maybe it's this one. I don't know. We'll see. Okay. So let y equal something to the power of something, and we're going to prove that the derivative means that the n comes down in front and then we subtract 1. That's the power law. We are going to prove it using algebra. Okay, so to prove it, we start with our equation given. To prove this guy, we're going to use what we just learned, the logarithmic differentiation. So let's do the logarithmic differentiation that we just did for 4 examples. It's fresh in our heads. So I've taken the natural log of each side. At this point here, you're in the log law world. Remember, your left side is patiently waiting. And on your right side, you use any log law that exists, which is the power law. So that n plops down times ln of x. And that n is totally gone. Okay. Now, step 2 is you can actually take the derivative of each side, right? So I'm going to take d of x, derivative of each side. Okay, so just like we were doing for those 4 examples, your left side always becomes the same thing. 1 over y dy dx. All right. When we take the derivative of the right-hand side, this is something you're going to have to remember. This is not a product law for derivatives because n is a constant. Remember how we were talking about how I said if there's a constant in front, you just recopy it? That's what n is. In theory here, n is actually a number. If we were doing this for real, that number would plop down in front, and this big fat n is actually a coefficient. How did I tell you to deal with those? Just to recopy the n, and then take the derivative of ln x, which is 1 over x. Okay, then the next step I said I always did was I always just simplified my right side. All I can do on my right side is that. So I've got n over x. Okay, at this point here, what did we always do? We multiplied by y so I could cancel and isolate. So now I have dy over dx isolated. Okay, then what did I always do? I always replaced y with the original expression. So none of this proof is actually anything new. We just did 4 really hard examples of it. Okay, this is where some exponent laws have to come into play, some like grade 9 stuff, okay? Because we need to kind of manipulate this and actually bring those 2 terms together, okay? So here's how we're going to do it. If I am trying to prove that I have an n minus 1 in my final answer, how am I going to get the minus 1? I'm going to get that by bringing my x up. Everyone see what I did there? My denominator x is now up. Now I've gotten 1 step closer because I have that minus n, and that is still multiplied to my x of n. Okay. And then, remember, this is a number. Picture that n is a 3, so we're kind of just ignoring it, okay? I have 2 identical bases, right? They are multiplied together, right? Grade 9 exponent law says when you have 2 identical bases with exponents on each of them, you add them. That's a grade 9 exponent law, so let's do that. I'll do that over here. Almost done. Proofs are long. So we have a big fat n, and then that is multiplied to x negative 1 plus n. So I've just added my 2 exponents together. And to make it look perfect, we can just flip these 2 around. No big deal, n minus 1. And we just proved it. You plop that n down in front, you minus 1 off. So that's a proof of the power law, okay? So that one, who likes that one? Who's going to maybe use that one next week? Okay. And there might be like a bonus question where you like do another proof too. I don't know. So like it might be wise to learn two. Not sure if you want to take me up on that, but okay.